Thank you so much for being here. It's an honor to be here. My name is Paul Turley. I'm a data platform MVP affiliated with Microsoft. I'm an independent consultant in the Portland, Oregon area. I live in the other Vancouver, down south. And I'm here presenting with Brian Grant. I'll let him introduce himself.
Hi, my name is Brian Grant. I'm here with CSG Pro from Portland, Oregon. I am a data nerd turned data professional. And one of my very, very, very favorite things to do is going to be what I'm doing here today, which is showing people how not only is this stuff not all that difficult as you might think it is, it's also a lot of fun to do. So I'm going to be I'm very happy to be here today.
Yeah, all right. Okay, well, let's talk about what we're going to talk about. So our stated objectives are to talk about advanced data transformations and shaping techniques. Again, the emphasis in this session is going to be practical techniques, stuff that you can use. We're not going to be pushing the envelope a lot. We're not going to be showing you brand new features like you've seen from the product team. But we're going to focus on transposing, pivoting, working with structured data sources. We're going to explore M. We'll talk both about the menu-driven features, but primarily some of the more advanced features driven by the menus, and then we'll get into the data mashup language. I was very happy to hear Matt Mason in the last session say that M is now the official name of this language. They've had this subtitle every time they referred to M, the unofficial name for the Power Query formula language, and now we can actually call it that. So it took 5 years to get that through legal, I think. So we're going to talk about error handling and management. That's important in any analytic or business intelligence solution. And then we're going to talk a little bit about creating and using query functions and parameters and how you can reuse code and kind of build your own library of useful functions and code techniques. All right, we're going to just start with a very, very high-level talk about query essentials. Brian and I have co-developed and have delivered some training on all things Power BI, and as we normally start out with very, very, very basics in workshops. So you think about data acquisition and transformation, traditionally in IT projects called ETL, extract, transform, and load. That's you go connect to data sources, and you have to reshape and cleanse that data and get it into a form that can be presented into your data model. So you think about data transformation as designing assembly lines for your data, and that's analogous to building something like a car. So in this example, we're saying that we have an assembly line in a car manufacturing plant where I'm going to start with the car chassis. That's my source. And then we're going to go through various stages of getting the chassis, putting the engine on it, connecting the drivetrain, testing the connection, making sure that it's working. And then there's a deliverable product at the end of that assembly line. And maybe that goes into another assembly line. Maybe it's just a component that needs to go together in building a holistic, in this case, a product like a car. But working with data is much the same. We start with something, we have these transformation steps, we have to clean it up, and we test it, and then we deliver an end result. So I love that I can say Power Query. It's just Power Query.
I know.
The gut data experience or Power, whatever you want to call it. There's this thing, and it all works the same way, regardless of the tool that you're using. These individual stages are applied steps. Now, I've used a lot of other data transformation tools. Early in SQL Server, I started with DTS, and then SQL Server Integration Services, SSIS. And those are great tools. They're mature tools, but boy, that's refreshing to use this particular tool by contrast. So when you click buttons and use menu options within the Get Data experience within Power Query, you're actually generating mscript. So here's some examples of some very common transforms, like use first row as headers. Well, that actually calls the promote headers function of the table class. When you convert a value to a specific data type, you're performing a transformation, et cetera. So you're always actually building this mscript, whether you're exposed to the script or not. And not all users are going to use mscript. Not all users are going to need to go this deep. But it's always there under the covers. So one of the things that I really do appreciate about this experience is that you can always see what you've done and see what your steps are going to do. And if something breaks, or if you need to go back and kind of remind yourself about where you've been, I see this as like an open reel tape deck. Now that dates me a little bit, but it's this idea that, well, I've performed all of these steps, and let's say I did this weeks and months ago, and I can't really remember exactly what I've done. Now I'm getting an error, and I really like to go back and debug and fix that. And I can actually rewind through that process, and I can stop at any one of those steps, and I can see the state of the data as it would exist as of the completion of that step. So if we go back and look at the source, I would look at the data in the form that it was imported from. If I went back to this step, I could see the result of this filled down action and just see the data in preview at that step. By default, up to 999 rows of preview data. This is just a marvelous experience. It lets me very quickly kind of teleport through time and see where I've been. And if something breaks, I could go back to a certain step and either fix that or just delete everything after and build forward. It's just a marvelous experience. All right, well, let's talk about transforming and shaping data. So we're going to look at 3 different examples. These are very common examples of data that I might import that is not ready to be loaded into tables in my data model. So key value pairs or pairs of lists. Here's an example. This data, by the way, that we're working with is from the Bureau of Transportation Statistics. It's the FAA's airline on-time performance data. It's publicly available data. There's a lot of it. It's very relevant. It's easy to understand. So these are our distance groups where I have a code that has an integer value, and then that has a text value associated with it. But you can see that it's in this list that isn't really in tabular form. Here's an example of some structured data. So if you've worked with XML in the past, or JSON, which is a little more popular now, JSON is structured data. And Brian's going to kind of talk us through how to think about working with structured data and navigating that. Anybody working with data that gets exported from a report? Yeah, yeah. Isn't that just a wonderful experience? It's like, somebody runs a report and they export it to a text file. You got all this junk at the top, junk in the middle, a page number somewhere in the middle. Well, we can work with that, but it takes a little bit of work. So we're going to talk about how you can work with that data. All right, so working with structured data. XML and JSON are primarily the data structures that are both multi-level and hierarchical in nature. What's unique about these document types is that they contain both data and metadata. So it's self-describing, and it can be multi-level. So it can support different hierarchies, and you can explore records at different levels. So here's an example again of that delay code data. And you can see that there are 2 levels to this data. And Brian's going to explore this, so I'm not going to take you through this. But we want to take that, and we want to transform it into this, into tabular form, so that we can load this as a lookup table into my data model. And so with that, I'm going to turn it over to Brian.
Thanks, Paul. So the first thing I want to say about working with JSON data is it's hard to think about if you haven't worked with it before. So when you're working with CSVs or a SQL Server or anything like that, or Excel, you think of data as this sort of flat object, right? There's rows and there's columns. It's like a poster that you can hold out in front of you, but it's flat. With JSON or XML, it's actually more like a 3-dimensional object, right? And so you don't think about what you see. It's not quite what you see is what you get. You have to navigate it the same way that you would navigate something like a house. So what I'm going to walk you through right now is that navigation process. So here I am. Everybody can see, I think, or at least I can. So I'm going to go ahead and right-click here on my folder. I'm going to get a new query. I don't see JSON here, so I'm just going to go to More. And I'm going to go ahead. I see JSON. I'm going to double-click on it. And I'm going to go find my JSON data, because I didn't leave this in the right folder. Let's see, Center JSON. So delay JSON, there we go. So when we click Open, we're going to get this experience that causes a lot of people to say, never mind, I don't care, I'm not going to figure it out. So you end up with something like this, and you call tech support and you say, this is not my data. What is this? I asked you for data, and you give me this. This is nothing. So again, this is a 3-dimensional object, right? So imagine you're in a room. This is like you go through the front door, and now you're in this room in this house. And you see 3 things. You see a piece of paper, and you see 2 other doors. You look at the piece of paper. On the title of the piece of paper, it says document name. And then on the actual content of the piece of paper, it says delay group info. That's not what you want. Drop the piece of paper. Then you see these two doors. You see door number 1, it's called delay group info data, and door number 2, metadata, right? So each one of these things is like a door. So behind these doors is something else. So you might be tempted to actually immediately go through one of the doors, but if you're like me, you're a little skittish, a little cautious, so we're going to peek through the door first. So if you hover over the thing that looks like a hyperlink, if you click on it now, you're going to go through the door, but if you just go off to the right a little bit and click there, you're going to get a preview. You're going to peek through the door. So we look into this new room and we say, there's 2 pieces of paper in there, one called create date, one called create time. That's not what I want either. All right, wrong room. Let's look at this other room. Let's peek through this other door. So I peek through this other door, and sure enough, yeah, that looks like the data that I asked IT for. So we're not, we were peeking right now, but we're done being creepers. We're actually just going to go through the door. So I'm going to click on it. And boom, there we are, okay? Now, if you're saying to me, hey, Brian, this still looks a little different than what I'm used to, that's because this is a record. Does it matter that you know what a record is? No, not really. It's like a table that's only got 1 row in it. The important thing to know is all of our cool transformations work on tables, which are not records, so we have to convert it. Is it really hard to convert it? Well, no, not really. You see that there's only one big giant button up here that says into table. That's the button you hit. So all you have to do is find the only button on the screen and hit it. Okay. So now we're into something that looks more like what we're used to. We're going to go through some sort of standard stuff. We're going to promote the headers here, so I'm just going to do the shortcut. I'm going to click on this little guy up here. I'm going to say use first row as headers.
It's about 18 different places you can find that feature, by the way.
Yeah, it's great. It's actually really nice. It's nice to be able to just sort of go back and forth like that. Okay, now I see my other real big problem. We have ABC, 1, 2, 3. Now, whenever you see something like that, what that means is that this is a column that isn't strongly typed. This is sort of an any type column, but we don't like that in Power BI. We want something to be either decimals or text or something like that. So whenever you see ABC, 1, 2, 3.
Okay, now hold.
Oh wait, Paul has something queued up.
Let's pause right there. Will you choose the code column? Just not there. Just choose the column.
Just choose it.
I just want to point out, if you look at the menu up here under data type, right here, it says that's the any type. One of the first things that I learned about Power Query, and probably one of the most important lessons I think I learned, is that any is really bad news.
Right.
Right. And so anyway, I thought because we want to make a point that whenever you see the ABC 1, 2, 3 icon, that is bad news. You always want to fix that. You are never going to forget that you need to do this. Okay, go ahead and transform it.
All right, so, hey, if you want to fix the ABC, 1, 2, 3, is it hard? No, it's easy. Just click on the button.
Okay, I can't turn my phone off now.
Okay. That's another room, another session on how to turn the sound off your phone. And I'm just going to go ahead. Actually, it's already sorted. I'm just going to left click and drag this. And boy, there's more I could do, but we're short on time, so I'm going to leave it at that and hand the microphone back to Paul.
All right, thank you. All right, so that's working with structured data. So the next thing we're going to talk about is transposing data. A few different ways that you can transpose data, and it's not just as easy as this. There are actually more options than just transpose, pivot, and unpivot. But categorically, we're talking about taking data that is structured, but it's in a shape that's different than we need it in. And so transpose means that essentially we're going to take all the columns, we're going to rotate the data, and we're going to turn it into rows. Whereas pivot and unpivot kind of categorically mean that you're going to pivot on something. You have to have something to rotate on, and then you're going to either rotate that data in one direction or another, and either grouping or typically aggregating. And so we're going to pivot data, all right? And this is one way that we can pivot data. So if we wanted to pivot data, before we can pivot data, we need to figure out where we're going to rotate. So we need to put an anchor somewhere. So we're going to put a thumbtack in the upper right-hand corner, and now I can pivot data. All right, I know that was really, really corny, but again, you're not going to forget that. All right, well, let's look at some other data that we want to pivot. So we've got this data that's in this really weird form now, and it's not structured like JSON data. It's not really a key value pair, but they're alternating records. And so on one record we've got the code with the actual field name, and then on the other record we have the actual value. But we don't really have any way to associate those with each other other than just knowing that every other record are pairs of records. And so Brian's going to show us a technique for working with that and getting it transposed or pivoted into this form.
Okay. So I'm going to pop over here to my second example, okay? And so the first thing I'm going to do is I'm going to look at this and I'm going to say, okay, I'm going to go look for the please help me button or get me out of here button. When I can't find that, what I'm going to do is I'm going to say, okay, first things first, whenever I see a bunch of blank rows, I'm going to get rid of those. So I've got column 1 selected. I'm just going to remove rows. I'm going to remove blank rows. Okay, that's always a good first step. Simplify that a little bit. And what we see is we have these values here, but really there should be like 2 additional columns. There should be a code column and a distance group column, right? And that's our hint that we want to pivot this data, right? This fundamentally, we need to add columns to this table. The problem is that
we need a thumbtack.
We need a thumbtack. So we're going to create a thumbtack, right? What we need is we've got this column 1 which says, what column is this data going to belong to? We need a new column that says, all right, what row is this data going to belong to, okay? And that's pretty darn easy. So I'm going to head over here to add column, and I'm going to add a conditional column. And what I'm going to do is I'm going to say, okay, go check to see, I'm going to call this row number, and I'm going to say, hey, go check to see if column 1 is equal to the text string code. If it is, go get the value from column 2, right? And what that's going to allow us to do is uniquely identify these pairs to a specific row, okay? And I don't need to fill this out. It's automatically going to just turn it into nulls. And so when I hit OK, notice we're going to have the 1 null, 2 null, 3 null. This is about halfway there. What we need to do now is take these nulls and just sort of fill them down. Now, luckily, there's a button to do just that. So we're going to fill down in a second. And if you haven't used fill down before, what it basically means is anywhere there's a null, it's just going to look for the value above it and just sort of drag it down.
I think this is where they've mimicked behavior in Excel because it was familiar to people.
Right,
This is a lot like the fill down feature in Excel.
Exactly. So how hard is this? Very easy. We're going to right-click on there. We're going to go down to fill. And we're going to fill down, right? Great. Now, for all of our values here, we've got both what column they need to end up in and what row they need to end up in. So we can go ahead and pivot it. When you're using the pivot feature, what you want to do is you want to click on the column that's going to get turned into new columns. So we're going to have 2 new columns called code and distance groups. So we're going to click on this column. We're going to head over to transform. We're going to click on the pivot column button, right? And it's going to say, OK, that's what you're going to turn into new columns. Where are the values that you're going to use to populate these new columns? Well, those are here in column 2, right? The last thing we have to do is we have to say, by default, what it wants to do is it wants to just tell you how many values are at those intersections. That's not what we want to do. We want to have the actual values. So we're going to twirl down here, aggregate value function. We're going to switch this to don't aggregate, right? Then we're going to go ahead and click OK. Just as easy as that. We're most of the way done. Yeah, very nice, very easy. So I see an ABC 1, 2, 3, but you know what? I'm not going to keep this column. So I'm going to go ahead and remove it. And I see that this is called text right now, but this doesn't look like text to me, so I'm going to convert that to whole numbers. And there's a whole bunch of other stuff I could do, but again, we're pressed on time, so I'm just going to hand the microphone back to Paul.
All right, easy peasy. Once you figure out how to do it, it's easy stuff to do. All right, error handling and error prevention. So I've been working in IT-driven BI solutions for, depending on what you count, 20 years. And when you're working in IT solutions, you're working in solutions that you're going to deliver to the masses, need to be supported, and they're going to be there for a long time. We think about data quality as this imperative. The data has to be perfect. And sometimes the data doesn't have to be perfect. And a common conversation that I have with potential consulting clients is, it's possible to clean up all of your data, but what's it worth to you? So really, there's kind of this logarithmic curve that if we need the data to be perfect, that's going to cost you a whole lot more than if most of the data needs to be perfect. So this is a big question, I think, that whenever you're dealing with importing data, bringing data from different places, data quality is always a reality. So the big question here is, must the data be perfect? If you're doing analytics and you need a statistical viable sample, and 99.9% of your data is clean, maybe you don't need all of that data to be perfect. So if it does need to be perfect, then you're going to need to investigate possible error conditions and then figure out what to do when you encounter those errors. You can either prevent erroneous data, and so your Power Query design experience might just be a way of figuring out that there's bad data and then and formulating a plan to go fix that data at the source. Or you may clean up the data as you go. So we're going to correct the data within our query itself. Then we're going to evaluate it again. Is the data perfect? Is everything right? Are we at a point where the data is acceptable? And if so, we'll go ahead and proceed with the data load. All right, let's look at the other branch. All right, so again, I'm an analyst. I need to, this is not healthcare data where, we're dealing with the lives of patients. This is not, financial records where, our general ledger needs to necessarily balance where every record is correct. But, we're dealing with a massive amount of data, and we just need to get a statistical sampling for analysis. And if some of that data is bad, it's okay. Let's get rid of it. All right, so it doesn't need to be perfect. So are the errors acceptable, yes or no? If they're not acceptable, then we're going to have to go back to square one and figure out how to deal with those erroneous records. Maybe that's just a percentage of our data. But we may just trap or redirect the erroneous rows. Well, now I've got really two choices. So I've got bad data, and I'm saying, that data is okay. Are we going to correct it, or are we just going to throw it away? And do we need to keep it around? Do we need maybe a data steward to look at it and go back and evaluate it so that we know what the bad records are, or not? And then we'll proceed with our data load. All right, so let's take a look at data error handling techniques. I think this is yours, and then this is mine. I forgot what we planned to do with this one.
I can go ahead and do this guy, and you can do the next one?
Yep.
Okay. So what we're going to do here is we're going to go ahead and create what I call a data jail, right? So we've got all these rows. Some of them are bad, right? So we want to reroute those to a separate table so that the data steward can look at them, okay? So what we're going to do is I've already got some of these guys set up. So I've got my initial query here, right, where I've filtered out some columns.
This was this is
Proceed.
what I practiced. we coordinated several times.
Yes.
So we essentially we're just going to walk through what we've done here. Generally speaking, if you've identified bad rows, and if I were to import this data right now after setting data types, you would find that some of the data is going to throw errors. And so let's just take a look at what some of those possible errors might be. First of all, we see that the flight date here was a date before they invented airplanes. And so it'd be impossible to have flights that left on January 1st of 1900. Secondly, as we're matching up our airport codes, you would also see that we've got some airport codes that don't match up. So there's an airport code right there. There's a whole bunch of Z's. And finally, if we look at our departure dates, or our departure delay value, we've got some bad records in here as well. We've got some numeric values that are out of range. So I can simply just do a search and replace or filter out those records. So one way or another, I'm going to create a version of this table that is all cleaned up. And I've just used replace values, and I've done some filters, as you can see in the steps here, to get that cleaned up. But now, essentially, I'm working with an audience who are saying, well, yeah, I cleaned up your data. But they're saying, well, what data was bad? We need to go back and clean that up. So what we want to do is create a table of values that I can give to a data steward. I can give to somebody who's responsible for this data and say, look, this was your bad data. You need to go either tell me that it's okay to throw those records away, or take ownership of that and clean it up, formulate a plan. So since we've already cleaned this up, but we still have our raw data, what I want to do is I want to compare the two, and I want to populate a table with those bad records. So this is what I'm going to do. I'm going to start with the raw data, and I'm going to create a reference copy. We'll talk about reusing objects a little bit later on. You have two options here. You can duplicate a table, which really just means that you're taking the entire table definition, you're just copying that. If you were to make changes to the original table, that they wouldn't be reflected in the second table. Or I can reference an object, reference a table, which simply means that my first table is really the master copy, and I'm just pointing to that. So that's going to be my bad records. So I'm going to take that copy now, and I'm going to merge it back to my cleaned copy. Let's go back to the home ribbon, and I'm going to do an append. And I'm going to append that. Wait. Sorry, this was a merge, wasn't it? I'm going to merge that. And I'm going to merge it to my cleaned records, which is this one right here. Now, another key thing is that I have to have a way to match up those records. And so we'd actually generated an index. It's just a row number. And I'm going to use that index to join these together. Now, if you, do we have Zoom it running?
Yeah.
Okay. All right. So if you've worked with relational databases, you'll recognize some of the join types here. But there are actually some very interesting join types that you don't really have simple equivalents in something like T-SQL. And I'm going to use the left anti-join. And that's essentially going to only give me the records that don't exist in one of the two records. All right, so we're going to do our left anti-join on that index column. We'll go ahead and do that. And that's going to give me my bad records. So this is the table that I could go ahead and populate in my model, or I could just keep the query and export it. And then that's my reference of bad records. All right, I believe that is it. All right, let's talk about M. All right, so as of today, at least the first time I've heard that we can now officially refer to this as M, or the data mashup language. This is just a cool language. It's a very powerful language. At last count, and this was circa January, February, I counted 645 different functions within the M language. Every time we get a new data connector, we get a whole bunch of functions associated with that. So a lot of the functions are data source specific. But relative to M, we're going to just take a look at some basic functions that are commonly used. We'll talk a little bit about different objects that you can use. And in Matt's session, he actually enumerated all of the different objects and talked about what all of the objects are used for. But at a high level, queries, functions, are parameters. You also have classes within M that are used to instantiate things like lists, tables, rows, etc. We'll talk just very briefly about some of the language basics, and then we'll take a look at using variables, parameters. We're going to show you a neat technique that you can use. There was a question earlier about documentation. Where do I go for documentation on this stuff? This is a self-documenting language. In other words, you can go ask it for its documentation, and it will show you examples of all of the individual functions, and you can actually get a description, and sometimes with examples, right within the product itself without going to a book or Googling or Binging the problem or the function. All right, so if you're building an M script, you can just start with a blank query. And in the formula bar, you can call a function just by using the equal sign, or go to the advanced editor, and then you have a little bit more control at that point. Some simple examples. This is an example of a list. So a list object can be created using the curly braces. I come from an MDX background with analysis services, and we use those for sets. It's still a relevant concept, though it's a different type of object. But to create a time lookup table, for example, I needed a table with one record per minute of the day. So if you do the math real quick, that's 1,440 minutes, the first one being 0. I would create a list from 0, 1439. That's going to give me one row per every minute of the day. I can do some simple math on that to actually populate that with every minute of the day. If I'm working with dates, now how many of you are working with models where you need a date lookup table or a date dimension table? Okay? How many of you are working with models where you don't have dates? That's actually a lot more rare. So this is very, very common. And you can use different techniques and different tools to create a date dimension or lookup table. You can do it in T-SQL, might be in your data warehouse, or you can do it here. You could also do it in DAX. And I would say that if you don't have your date lookup table in your source, this is the right place to create it, as opposed to using DAX. So if I can keep all of my queries in one place, they're going to be a little easier to manage. All right, so we'll take a look at how we can create a date lookup table. This is a very common technique. And go ahead and switch over, and I'll show you how to do that. So I'm just going to create a blank query. There is I think it's a bug in the product. I've seen a number of people experience this. You go to drop down new source and it doesn't drop down. So I just click on the button. So we'll go down to other, and I'm going to create a blank query. Now, I have this script prepared because I never type in demos, but let's pick this apart And I'm going to go to the advanced editor to do this. And oops, let's do it in the formula bar, my bad. Okay, so if we zoom in on this, you can see that, oops, let's do that, and zoom in like that. All right, the first thing that you're going to see is that the list.dates function or method, if you're come from a programming background, has 3 arguments. So it wants a beginning date, it wants the number of periods, and then it wants a duration. Now I could use this with time, I could use it with dates, I could use it with months. So the first thing I'm going to do is just get a date value, and I can do that by using this constructor. So they're a class of functions that begin with a pound. They're all lowercase, and these are used to construct a certain kind of object. In this case, I'm constructing a date, and that date constructor function needs 3 parts to it. So I'm going to pass it the year, the month, and the day. So that returns a date object with that value of January 1st, 2015. The second thing I need is the number of periods. Now, I don't know exactly how many periods I need, but if my objective is to populate this with about 20 years of dates, then I'm just going to go out past that, and I can always filter the resulting table. So I'm just going to take 365, multiply it by 21 to account for leap days and anything left, and I'll just pick December 31st of whatever year I want after that. It's 2035, I guess. And then the last argument, the third argument, is this duration. And the duration object, it took me a while to kind of memorize this and think about it. But duration is days, hours, minutes, or seconds, or any combination of the two. And if that's not easy to remember, if it doesn't seem familiar to you, I'll just say that this is the way it works. So that third argument, I'm just going to pass it a 1 in the first position, which is days, and it's just saying, all right, the number in the second argument represents days. So let's go ahead and press enter there. That's going to create a list. And this menu has, notice that the mouse pointer has gone away. That is awesome that I can't see the pointer. Hopefully it'll come back. No, that's even more awesome. All right, maybe that'll work. Somebody's playing tricks on us. Have you had this happen on your laptop before?
Yes, I think sometimes Zoom it will cause it. So let me try and
rerun it must Zoom have been. We'll blame it on the
so when in doubt, yeah.
Yeah, we'll blame it on the unofficial Microsoft screen zooming tool.
All right. Okay, so can I hit? No.
Nope.
Okay. So can I do it this way?
Yeah. Well, if you can get down to Task Manager, then kill the process.
This is an interesting challenge.
Yeah, it is.
Okay.
It'll come back. The pointer might come back.
Yeah, so let me zoom it.
Actually, I did this purposely just to make Brian
Brian
sweat.
do this by hand,
Of course, I'm doing the demo, so I should be sweating.
Yeah.
Any questions at this point?
Yeah.
Yes.
So, are you really suggesting that we could use Power BI transformation functions instead of SSIS transformation?
So the question is, am I suggesting that we use Power Query, get data, in place of a data transformation tool like SSIS? If your target is Power BI or analysis services tabular, yes. I think one of the reasons that Power Query is as elegant and easy to use as it is that it's optimized to deliver only Vertipack tables within Power BI or a tabular model. Where a tool like SSIS or DataStage or Informatica, these very general use ETL tools, they have all kinds of flexibility, and you can export tables anywhere you want. So yes, within that box, I think this is a great tool. You look like you may have a follow-up question.
Two, if it's okay. So it seems to me that this is a step towards revolutionizing how we're dealing with making data marts, or what I think of now more formally than data marts or warehouses, or data pools, right? Functional or process-driven data bites. You know what I mean?
Yeah, I do. And we're kind of hedging on a huge topic here. And let me try to simplify this a little bit in the little bit of time we have. So, can I use Power BI or analysis services as a replacement for my data warehouse or my data marts? No, absolutely not. However, within a certain scope, I think that we can do that as long as we're very crafty and very disciplined about utilizing our data sources correctly. I've looked at a number of just interacting with folks here and answering questions and such. I'm seeing a lot of solutions where the tables that are being fed into Power Query and into the data model are these hideous queries and just garbage that would be really hard to maintain. And no, you can shoot yourself in the foot and get in a lot of trouble by doing that. So, I mean, that's a religious discussion, and yeah. So, it's a great question, but I mean, I spend months and months working through problems like that with clients. There was a question over here.
You mentioned referencing tables that use duplicating the queries themselves. When you reference them, how does that impact the relationship later on? Can you still relate to different tables?
Absolutely. Okay, so the question is, how does reference differ from duplicate? So duplicate means we're taking that block of M code, we're making a copy of it, and now table 2 looks like table 1, but if I make changes to table 1, it doesn't change table 2, and vice versa. If I reference table 1 to create table 2, they're the same, and as far as Power BI is concerned, table 2 is just as compatible. I can create relationships, I can create calculated columns and measures, blah, blah, blah. But if I make a change to table 1, that change is going to be reflected in table 2. It is truly inheritance. It's a polymorphic behavior.
Even with the DAX later on, or no?
There's no difference with the metadata. Table 2 is a table and is just as compatible as if I had used table 1. Yeah. How are we doing, Brian?
So one of the most important things to do whenever you have a problem like this is threaten to close Windows, and it'll actually fix a lot of your issues. So you've got the mouse back. The other most important thing to do is make sure you have a finished copy of all your examples waiting to go.
Yes.
So we're able to step back, I think, to about where we are, and if we just give me just 2 seconds, I think we're going to be ready to go.
All right. Grace under pressure. Big hand for Brian here.
This is all part of our demo, by the way.
Thank you so much. All right.
This is our way of sneaking the Q&A sort of into the middle of the session.
All right. So I'm going to, so first of all, the first thing I want to do, and I'm always going to do this whenever I've created columns in a table, I'm going to look for that ABC123. I'm going to look for that data type. Oh. Okay, just always remember that. It's going to be in your head for the rest of the day, I promise. All right, so we're going to change ABC123 to date, and we're going to change the column name to date. Normally, I'd be a little more deliberate with that, maybe flight date, sales date, invoice date. And then I'm just going to create my date part columns that I would have in any date lookup table. And so I can go to Add Column, and I'm going to go over here today. I love when they added this ability to go create a new column based on a function or another feature here. So I'm just going to create a year column. And you can see it types that as a decimal, which I don't like, but I'll go back and clean this up. So going back to date, again, I'm going to add a month. Now that means month number, and so I might call that month number, but in the interest of time, I'll leave it as month, but I'll also create a month name. So we've got a name of month or month name out there. And again, I'm going to pay close attention to my data types. I'm going to make that a whole number, make that a whole number, and make that, well, that should be text. It is text. Okay, so at least in simple form. Now if I wanted to do some really crazy stuff, I could go create my fiscal part columns. I could create my ISO part columns. Was it Jen who put together that date table script where she figured out how to do all of the fiscal stuff. Yeah, so people have some good examples out there. The folks at CSG Pro have done some great work to build out all of the script and build a function that will actually create fiscal tables and financial tables and such, using like 4, 4, 4, 5 calendars. Anyway, but there's our date table that we can use in our model now. All right, let us switch back. I think we're ready to rock and roll. Okay, so, let me actually show you the resulting code. I'm going to switch back to my advanced editor and just show you what this has created. So this was really the genesis of my date table. So that's that core code that I needed to write by hand. You know, someday we'll probably have a menu option for this, but you know, it's not hard to copy and paste that. But everything else was just using the menu options. Well, I could easily parameterize this. Now, in the interest of time, I'm not going to do that, but I'm going to switch to a slide where I'll show you that we can actually just create parameter values to feed into our query at this point, which would actually turn this query into a function that we could then call to create other tables later on. All right, let's go ahead and switch that back. All right, so here's an example of what that would look like. Let's just pick it apart a little bit. So I'm going to add my parameters here. I've got my start year and my end year. And as you can see, all I've done here is I've just replaced literal values with those input parameters. It's very simple. When you use the parameters feature in Power Query, just on the menu, you go create a parameter. You can just use that parameter within your query. It's that simple. There's very little difference functionally between a parameter and a variable, other than you'll be prompted for a reference parameter. There's a UI for that. All right. And then here you can see the code that was actually generated that converts the list into a table, and then each of the individual columns that were added. And then, as is standard in Power Query M, the last table variable that was generated by the designer is the object that you actually return from the query. All right. So we talked about this a little bit, and to this gentleman's question a little bit earlier, the difference between duplicate and reference. Duplicate creates a copy of the query, and they're completely independent. You've branched your code at that point. Reference means that the source of the resulting query, after you've right-clicked on a query and said reference, the source is the other query. And so, again, it's this polymorphic behavior. It simply means that Table 2, resulting from query 2, actually inherits from or starts with the table generated by query 1. We can create a function. We can very easily turn a query into a function. Brian's going to show us how to do that, so I'm not going to go into it. But there are some very useful techniques that are kind of used to build this along the way, and one of them is called extract previous. And Brian's going to show us how to do that. And Brian is now going to demonstrate how we can use function-driven query design techniques to avoid the zombie apocalypse.
That's right. So, take your notebooks out. This is going to be really important stuff. Your survival is based on it. Okay, so you ever had a situation like this, right? You get an Excel document that's got your data, and you get it from a reporting service, and it's got all this like header stuff up at the top. It's got the name of the company that built the reporting service. It's got when it ran it. It's got all these like spaces in between everything. It's got page numbers. It's got all this junk that you don't want, right? So you spend like half an hour getting rid of all this stuff, and you're really happy because you finally got the data that you want. Then you open up your second report, and it's got the exact same problems. And you open up the third report, and it's got the exact same problems. And the fourth report, the exact same problems, one after the other. You're solving the same problem over and over and over again. It's sort of like, in the zombie movies, right? So you're in the garage of your house, right? And there's a zombie, and you go ahead and you kill the zombie, and you get rid of it. Then you open the garage, and there's thousands of them out there. And you have to do this one by one. We're going to help you do this much, much faster, right?
Kill the zombies.
Kill the zombies. So we're here in this report. So let's say we start with something like this. And we see we've got this header information up here. We've got the report number, because that's really important. We've got the date the report was run. Who cares about that? all these spaces, all this junk. So we spend all this time, we remove the top 4 rows, we promote the headers, we filter out the blank rows, we filter out the page number rows, and finally we're good.
So has anybody done this? You know, you go through all of this junk and then you want to be able to repeat it and apply it later? Good.
Right, and you have to do it like every week. You get a new version of this thing. So what we're going to do is we're going to say, all right, we've got these 4 common steps in here, right? We could turn these into a function, so we could use them over and over and over again. So the next time we get a bad report, we're just going to call a single function, and it's going to do all this cleaning stuff. This works with 4 steps. It works with 4,000 steps. Okay, so what we're going to do is we have to extract this stuff. First thing I'm going to do, I'm going to right-click on my query, make a duplicate of it. Never want to work on the original. And I'm going to rename this to FN Cleaner for function cleaner, FN Cleaner. Hey, Brian, it's not a function yet. Well, hold on. We're getting there. So now we say, all right, we've got to isolate the steps that we care about. So here's our 4 common steps. We're going to right-click on this last one and say delete until end. So we're going to delete all this step and all the ones after it. Okay, we don't need those. That's not going to be part of our function. Then we've got these steps up here, which go grab the initial table. Well, we don't want those either. So what we're going to do is we're going to right-click on the very first step, right-click on it, and say extract previous. So what that's going to do is it's going to take this function and cut it right down the middle. And that first part of the function that went and grabbed the source, that's going to be a new function, right? So I'm going to extract previous. And we're going to call this static source. So this is the source that's static. And we're going to turn it dynamic. Right now it only points one place. We're going to make it point wherever we want to. So I go ahead, click OK. Now I've got this static source query that we had a second ago. We don't care too much about that. And here we've got basically the guts of the function we care about. We want to take a table, remove the top 4 rows, promote the headers, filter out the blank rows, and filter out the page rows. Perfect. All we got to do now is convert this into a function. Okay, we're going to go into the advanced editor, but I promise it's not going to be that scary. Click on advanced editor. So what we got to do is we've got this source right now, and right now it points to a static source. We're going to make that point to a dynamic source. So what we're going to do is we're going to do the 2 forward double slashes, which means, hey, this is just a comment now. This is no longer part of the code. We're going to hit enter up here. We're going to add open parentheses, and we're just going to type in source. And so now, if I do my little arrow operator, what I've said is, okay, this is now a function, right? This step is something that I could sort of call and pass in a table to it. And whatever we pass in is now going to be this source object that's going to have the same transformations applied to it. Very, very easy. It's as easy as that. So I click done. This is going to change a little bit because this is now a function, not like a traditional query. But now we can call this cleaner, right? So I come over here to my next. I pull this open on Tuesday and say, oh, God, I got to do that again. Nope, no, you don't. What you do is you right-click on this step. We're going to insert step after, which is going to insert this dummy step, which just goes and get the step before. Well, we don't want to do that. Well, we're going to get the step before and apply our cleaner function to it. So we're going to do FN cleaner, open parentheses, and close parentheses, and just like that, it's clean. 1 zombie down, 1 zombie to go. Click on this guy right here. Again, go to last step, right-click on it, insert step after to insert a dummy step. We head up here, and we just wrap the whole thing in FN cleaner for our cleaner function. And just like that, we're done. And if we have to do this every week, we've saved ourselves a ton.
You have to spell it correctly, though.
Oh, well, yeah, that's always helpful. When I say this is the clear function, which is not near the cleaner function, not nearly as helpful. Cleaner. Boy, I'm just batting 1,000 right now. Cleaner. There we go.
Woo!
In another session, I had to type correctly later on. Just like that.
All right.
Great.
Fantastic. Thank you, Brian. I think that's our wrap-up. So this is the resources slide that I pointed to earlier. So the slide deck is up there for you to download. We will get the demo project. We made some tied up some loose ends last night, so we'll get that zipped up and uploaded as well. So by the end of the day, you'll have our demo projects as well. So anyway, you're welcome to reach out to us if you have questions, just remember that all of the recordings will be available after June 27th. And with that, yeah.
Yeah, I did have one thing I forgot to mention before everybody takes off. If you guys like that trick where we did the pivoting to solve that one problem, you want to see a more complex version of the same thing, Chris Webb's excellent book in the back of it has a variation on that. It's a little more difficult, but if you liked it, it's a very cool example. So please, go pick up that book. See that excellent example.
Yeah. So with that, thank you very much for coming. We appreciate your time. Hope you enjoy the rest of the conference.